In this video, we will practice verifying trig identities such as this one. Notice that we are just trying to show that the left side equals the right side. We are not solving for x, which is actually a common mistake. As we do this, make sure that you are able to recreate this chart. You should be able to take out a sheet of scratch paper right now and without looking, write down all of these formulas. Make sure that that is the case. So, I usually pick the more complicated looking side to work on, and then I try to make it look like the other side. So there is a trick to this problem. Notice that my chart is full of things that are squared. There's nothing on here that is to the fourth power, but yet here I have fourth power. So then I'm thinking, like, what am I supposed to do with this? You know. But look, do not panic. Secant to the fourth power is just the same thing as secant squared, right? If you square something that's already squared, that would be to the fourth power. Similarly, I have minus. Now this would be the same thing as tangent squared x squared. Alright, so think of it that way. So obviously I've chosen to do the left side of the equation here. Alright, so I'm going to stick to the left side. I will not touch the right hand side at all, and I will go straight down. Do not go horizontally. Don't do your next step to the right. Put your next step underneath and underneath and underneath. So I'm about to do this substitution. Secant squared is equal to 1 plus tangent squared. Okay, I will be slightly more comfortable though if I put tangent squared plus 1. So I'm allowed to do that, so that's what I'm going to do. And don't forget this is still squared. Now tangent squared, okay, tangent squared is equal to secant squared minus 1. So I'm going to write secant squared. Actually, maybe I won't do that. By making the substitution, I'm getting all tangent. So that was about to be silly. So I'm going to actually leave this one alone so I can just have all tangent. So I'm going to leave this as tangent to the fourth power x and hope for the best. So I'm going to bring down my tangent to the fourth power. Okay, great. Now I need to square this, but I need to do it right. I need to do tangent squared x plus 1 times tangent squared x plus 1. Alright, that's how you square a binomial. This will be tangent to the fourth power x. Okay, so I need to FOIL this or double distribute, whatever you want to call it. Tangent squared times tangent squared, that's going to be tangent to the fourth power of x. And then from my next two terms, you know how I always say inner plus outer equals middle. Alright, inner I have 1 tangent squared, outer I have 1 tangent squared. Together that is 2 tangent squared x. And then 1 times 1 is 1. And then I have minus tangent to the fourth power x. Okay? Mercifully, tangent to the fourth power and negative tangent to the fourth power wind up canceling each other out. So we are moving in the right direction. And not only that, but this is basically what I'm trying to find. But I just want these terms to be in the other order. So I can just go ahead and write 1 plus 2 tangent squared x. And that is my target. So I'm just going to go ahead and put a box around that and call it a day. So looking at this one, I think I will do the right hand side. It looks a little bit more complicated, so hopefully I can simplify that down and it will come to look like the left hand side. So I'm doing the right hand side. So I'm going to start by doing the distributive property here. So that would give me cosecant x times cosine x plus cosecant x times sine x. Okay, I'm just going to go straight down. Make sure every step is vertical. Don't put anything to the right or to the left. Just go straight down. Anyway, I'm going to rewrite cosecant as 1 over sine. Okay, you'll probably notice that these sine x's are going to cancel each other out, so that's just going to leave 1. So over here now I've got cosine x over sine x, alright, plus 1. Alright, but cosine over sine is the same thing as cotangent, so that gives me cotangent x plus 1. Then I look up and see, oh look, that is the target that I was trying to get. So I just verified that identity. Okay, on this one, I think I'm going to choose the left-hand side. I can see some moves I can make. I could have done the right-hand side, but I think that's going to actually take longer. So I'm going to do the left-hand side. So our number one strategy is to rewrite everything in terms of sine and cosine. So looking at tangent there, of course that would be sine t over cosine t. And then cotangent is going to be cosine t over sine t. Alright, so that's the numerator. And the denominator is already in terms of sine and cosine. So I'm going to leave this as sine t cosine t. Now I need like denominators so I can add these two fractions together. So I'm going to go ahead and multiply this by cosine t over cosine t. And I'm going to multiply this by sine t over sine t. Okay, so that's going to give me sine squared t over sine t cosine t. Okay, actually, I have like denominators, so the whole point is to put these together with a single denominator. So I'm not sure why I was writing that so separately. So I'm going to have sine squared t minus cosine squared t over the common denominator of sine t cosine t. Okay, now all of that is just the numerator. Okay, everything you see here is still just the numerator. I still have the denominator of sine t cosine t. I still have that. Now, we have learned that if you have a fraction and you're dividing by something else, the way you do it is just you put the thing you're dividing by in the denominator. So you would just get a over bc. Alright, just put the thing you want to divide by, just put it in the denominator of the fraction. So that's what I'm going to do right now. Okay, I've got this fraction, and now I'm dividing by this additional thing. So I can just put the additional thing in the denominator. Okay, so that's going to end up as sine squared t minus cosine squared t over, if I put this up in the denominator, now I've got 2 of everything. So this is going to be sine squared t cosine squared t. Okay, alright, I'm going to need a new column in case, in fact, I probably should have just written it up here. Sine squared t minus cosine squared t over sine squared t cosine squared t. Alright, just didn't quite have enough space down there. By the way, notice I cannot cancel out the sine squared t and the sine squared t because the minus sign, you cannot cancel out things when they're connected by a minus sign or a plus sign. But what I can do is this. If I have a plus b divided by c, I could write this as a over c plus b over c. Alright, let that soak in. So that's what I'm about to do right now. This is my a, this is my b, and this whole denominator is my c. So I'm going to split this up into two separate fractions. That's what I'm about to do. If I can get my eraser to work, do not crash. I command thee not to crash. So if I split this up, it's going to be sine squared t over sine squared t cosine squared t minus, alright, now I'm putting the denominator under the second term, so minus cosine squared t, that's that, okay, over sine squared t cosine squared t. Now you can probably see that now I can cancel out the sine squared t's. I'm going to need like a 1 up there, and I can cancel out the cosine squared t. And again, I'm going to need a 1 up here, kind of like as a placeholder. So now I've got 1 over cosine squared minus 1 over sine squared. And of course, 1 over cosine squared is just secant squared, and 1 over sine squared is cosecant squared. And that was the target. Alright, that one was pretty tough. Number 19 is quite easy if you recognize the shortcut. I'm going to do the left-hand side. When I see 1 minus sine theta, it reminds me of this identity. See the 1 minus sine theta? If I were to multiply by 1 plus sine theta, that would give me cosine squared theta. So that's the quickest thing to do. So the quickest thing to do is to go ahead and multiply by 1 plus sine theta. And of course you have to do 1 plus sine theta over 1 plus sine theta. Okay, but in the denominator, like I said, that's going to give me cosine squared theta. In the numerator, I have 1 plus sine theta times 1, so that will be 1 plus sine theta. And you're done. That's exactly what we were trying to get. Alright, now it would have worked to do the left hand side as well. Alright, we're done. This is just extra information. Imagine I had done the right hand side. Then I would have had 1 plus sine theta over. Now cosine squared theta, alright, as you see, I mean we're used to writing cosine squared theta as 1 minus sine squared theta. But let's use this instead because of what we saw on the other side of the equation. Let's write 1 plus sine theta times 1 minus sine theta. Okay, so if I did that, 1 plus sine theta times 1 minus sine theta, can you see what's going to happen? Alright, these will cancel each other out. And I will need a 1 up here sort of as a placeholder. and then that will give me 1 over 1 minus sine theta. And that's it. And then you've got your target. So there, I guess I just went ahead and solved it both ways. Number 20, I would definitely tend to work the left-hand side of the equation because it's got the plus sign in there that I like. So this is going to be 1 over tangent of beta, so that's sine beta over cosine beta. Alright, and then tangent beta, again, that's sine beta over cosine beta. Alright, now when you put 1 over something, that just means you're doing the reciprocal, alright? Because the next thing you do is multiply by the reciprocal. So this is going to be cosine beta over sine beta plus sine beta over cosine beta. Alright, well, we need like denominators, so that's why I'm going to multiply this side by sine beta, sine beta over sine beta, and I'm going to multiply this side by cosine beta over cosine beta. So that will give me cosine squared beta over, well, I can see I'm going to have my like denominator. So I'm going to go ahead and put this together now. So I've got my cosine squared beta plus my sine squared beta over my common denominator of cosine beta sine beta. Okay, but check it out, I'm gonna need more space. This is my favorite identity, right? Sine squared plus cosine squared is equal to 1. Love it. So cosine squared plus sine squared, that's just 1. So that's going to give me 1 over cosine beta sine beta. Alright, so I basically have simplified this right now. Now I just need to massage it to make it become secant squared beta. So how am I going to do that? Okay, so alright, these next couple moves might be a little bit tough to follow. But here's my train of thought. I see that the denominator is tangent. So I know I need a tangent in the denominator. So I'm thinking, how can I make this sine into a tangent? Well, if I had sine over cosine, alright, if I had a cosine beta right there, then that would make this tangent, right? Well, I can't just do that. I can only multiply by cosine over cosine. So I'm going to need an extra cosine beta. So I'm really doing cosine over cosine. But if you focus on this half, sine over cosine, this portion right here is tangent. Okay, so at this moment, here's what I have. Alright, so right now I've got 1 over, alright, now I've got that cosine beta, alright, that was right there. Now I've got my sine over cosine, so I've got tangent beta, and then I've got this extra cosine beta over there. Alright, so actually, so I've got my tangent beta, and I've got cosine beta and another cosine beta, the extra cosine beta. So I can go ahead and make this cosine squared beta by putting those two together. Now, I have the tangent beta that I wanted, but I've got this extra cosine squared beta that's not supposed to be here. So I'm going to move it up to the numerator. Now, when I move it, it's the same as doing the reciprocal. So you can move a cosine from the denominator to the numerator, as long as when you move it, it becomes secant. So I'm going to move this cosine up, and it's going to become secant squared beta, all right, because that's the reciprocal. And then that will leave the tangent beta in the denominator, and that was my target. Okay, this will be the last problem on this video. I'm going to take the left-hand side because it has the minus sign that allows me to get like denominators and combine the terms. And that usually works out pretty well for me. So tangent squared x is the same, the same thing as sine squared x over cosine squared x. So then I've got minus plain old sine squared x, right? You know, that'd be the same as like having over 1 if I really wanted to go there. I need like denominators though, so that's why I'm going to multiply by cosine squared x over cosine squared x. Alright, that will give me like denominators. So if I smash this together, that's going to give me sine squared x minus sine squared x cosine squared x over cosine squared x. Now looking at the numerator, I now have a GCF happening. See the sine squared x and the sine squared x? I'm just going to slide that off to the side. So that will give me sine squared x times 1 minus cosine squared x. That looks real familiar. Okay, over cosine squared x. Where have I seen 1 minus cosine squared x before? Oh, that's sine squared x. Well, theta, whatever. So this is going to be, alright, better make a new column. Alright, so this is going to be sine squared x times another sine squared x over cosine squared x. Am I going to make sine to the 4th power? Nope, that's not in my target. Why did I put my cosine way over on the left-hand side? Well, that was probably to make it more obvious that I'm about to do sine squared over cosine squared, which is tangent squared. And that leaves the extra sine squared on the right-hand side. And that is indeed the target. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.